we propose MotionDeltaCNN, the first sparse CNN inference framework for moving camera input. By aligning all frames with the first frame of a sequence, we are able to reuse previous results for coherent regions in the image. Naively aligning frames from different perspectives with previous frames either requires over-allocation or crops. MotionDeltaCNN solves this issue while allowing for infinite camera motion. We propose two new concepts for seamless attachment of new frames without having to allocate memory on camera motion. First, we propose spherical buffers. Analogous to ring buffers for 1D data, our spherical buffers map pixels that exceed buffer borders onto the opposite border of a 2D feature map. This way, we can reuse previously processed results for coherent pixels, while allowing for new pixels to be added on the fly and without additional memory allocation. Next, we propose padded convolution for seamless attachment of new pixels onto accumulated values buffers. With delta inference, adding new pixels along the border is non-trivial because of missing context of previous frames. When a new pixel is first processed, it lacks information from previous frames from its neighboring pixels and can only access their current frame's delta values. This leads to artifacts along the borders of previous frames. We solve this by padding the convolution and processing all pixels that are affected by the current input. For a 3x3 convolutional kernel, we process one extra pixel on each side of the feature map and store it in the truncated values buffer. Once the camera moves over the borders of the feature map, these truncated values are used to fill in the missing context of the neighboring pixels. Compared to previous work without moving camera support, MotionDeltaCNN achieves much higher update sparsity by reusing previous results. Even in scenes with slow camera motion, DeltaCNN requires near dense updates, while MotionDeltaCNN can reuse the majority of previous results.